Hi, everyone. Thank you so much for coming to the third Compute Over Data Summit. This is our second public one. We actually had a secret one that no one was invited now. And sorry about the power. We're working on it. Unlikely, but possible. The key next time, by the way, is there is power up here. So you should submit your talks, because then you get power during your talk. And you get the free recharge. Anyhow, so it's great to see you all again. I'm going to kick off the day to talk a little bit about what Compute Over Data is and where we're seeing it advance and so on and so forth. Because there really has been so much traction just over the past year and the past 6 months when we got together in Lisbon. I give this talk a lot. I've talked about this in particular. One of the reasons that Compute Over Data is happening now is basically the things you see on the screen right here. First is, there's this projection forward by 2025. We're going to have 175 zettabytes under storage. And we're starting to get into words that don't even seem to, aren't English anymore. Though I think that's Greek anyway, so there you go. But it's growing so rapidly, and it's growing rapidly everywhere. 57% of all data is growing outside of core enterprises and core enterprise data centers. So you're going to have to do compute over data whether you like it or not. In particular because it's so slow to move. Bandwidth growth is being outpaced by data growth by 45% year over year. And if you took that 175 zettabytes and wanted to move them at current speeds, that's 1.8 billion years, which is probably too long for most folks in this room. And finally, even if you could move it, almost 100% of it is under some form of governance: GDPR, HIPAA, SOX, so on and so forth. Just moving that data from where it is costly and painful. And so that's where you get 68% of enterprise data is unused today. So if it's that bad, what are people doing today? And it really breaks down into three big categories. First, they're using centralized systems. Second, they're building them themselves. Or third, they're doing nothing. And I'll go into each of these in just a second. The first is they're using centralized systems. So centralized systems look like this, right? We've all seen them: Spark, Hadoop, Kubernetes, Dask, Storm. They could be programming frameworks. They could be centralized compute clusters and things like that. It doesn't matter. They're all great, and they all serve a very important function in the ecosystem. But really, you can kind of all call them the same thing. They all have this central API server that you interact with. And it's fine. It does its job. It's quite good, actually. You have your system, you have your servers, and then you'll have a bunch of data that are sitting next to it. Now, your data scientist comes along and says, "I'd like to run some data analysis, please." And the central hands her job to the central API server. Central API server hands it to the data and gets the results back, and all that's fine. But the truth is, and the biggest problem is, that this isn't what people are doing today. They really want even more. Our data scientists might say that, oh, okay, I have some stuff over there on AWS in a different cluster. Maybe I have some data on Google Cloud. Maybe I have some stuff on a ship in the middle of the ocean or something like that. And then she says, well, I'd like to do that same data analysis, or I'd like to use the data I've now worked hard to collect over there in those other locations. Hands it to the central API server, and the central API server can't handle it, because that's not what they're designed for. They're not designed to cross that big black space in the middle there, a lot of folks will call a latency boundary, where things become irregular, or there becomes a significant amount of time between the compute you're looking to do your jobs on and the data that you actually are storing. So then someone very smart comes along, and this is where we get to our second scenario, and they say, well, I'd like to build it myself, right? That's possible. It's all software. She can build it. Our developer does that. She builds a new API server, and she builds her own custom orchestration system to a very specific need. And now our data scientist comes along and says, I'd like to run this outside, and she's able to do it because she built it to a very specific set of needs. And that's fine. Again, it's all well and good. Except now she would like to add additional requirements. And these requirements are constantly changing because our system, our world, the things that these are mapping into are also constantly changing. This could be things as simple as just scheduling against data locality. Oh, I want to go to whatever, Belgium, because that's where the data is and the data cannot leave Belgium, for example. maybe using green power, or maybe inside a single geo because that's where her customers are, collecting audit logs of exactly who accessed what data where. Maybe you target spot workloads or things like that based on how cheap the data is in these various locations, so on and so forth. There's lots of different scenarios that you'll approach today. And if you're using that custom one you built, bad luck, especially because she wants to go on vacation, right? So now you're in real trouble because your initial scenario that it works fine, but the moment you now need to extend it, you have to take on all the work to do that. So then we get to our third scenario of what they're doing, which is doing nothing. And you're like, what do you mean doing nothing? Well, let's say we have an example of many cameras out there in the world collecting data. And you have your data center, which collects all this data and ultimately runs processes on. If you were to take all of those video streams and shunt them into a single data center, we actually have an example that I'll talk about in a little bit of 4.4 petabits a day of throughput. This is, forget, whether or not your machines can handle it. Can your network even handle that? And the answer is almost certainly no. So instead, what this particular customer is doing is they set up nearby machines, in this case just monitors, that collect the data. We have our police officer, our doctors, our firefighters go and read these things locally. And then what do they do with it? They throw it away. They store it for 7 days or maybe some small amount of time, and they just toss it in the bin. And that's what it is. But at least it's not costing them millions and millions of dollars a year just to ingest. This is actually valuable. So the solution is, let's build together open source compute over data platforms. These are things built in the open. They're understood by people. They're community driven. They're governance driven. And they're done in such a way that people can customize with the needs that they have. So in this case, we have our scenario again. Our developer says, let's use an open source platform. She does. And what you get is, first and foremost, you get an open source and extensible platform. And again, this is so critical because there are going to be so many different needs out there that you're not going to know or understand or so on and so forth. It's built for multi-cloud because they are multi-cloud. These open source platforms are designed in such a way that they understand that they're going to have to address various locations. They're not owned by a single hyperscale vendor. They're often made for non-data centers. More often than not, your actual architects of these these open source data centers and platforms are looking to have things run on their services and can't do it because they're not hyperscale and so on and so forth. And most of all, even when our developer decides she still wants to go on vacation, they're maintainable because they're built by a community with community governance and things like that. And now we have the best possible scenario where both the developer and the data scientist are working well together. To take the similar example, now because you're able to address this in the open source and have these various things in these various locations, you take that example before where you're doing nothing with all those video streams. And instead, you say, hey, let's do something. Now, instead of streaming to each of those individual monitors, we stream to local servers that are running outside of your core data center, but nearby those cameras. And so those very thick streams of data and video that are going in are now going locally over a much higher bandwidth connection. They can be downscaled, they can be downsampled, they can produce metadata, and only that is what flows through the data center, which is much more addressable. Anyhow, there will not be, and this is something I keep coming back to over and over again, a single solution for all of these needs. This is something, we call it Juan's Triangle. Juan Benet, the co-founder of Protocol Labs, came up with this proposition that basically any compute over data platform will balance between one of these three endpoints. And you only get to pick a subset of them. For everything where you want more performance, that necessarily means sacrificing some privacy or verifiability, or vice versa. And you will pick the platform that most closely aligns with your needs. But what you're really looking for is some of those core elements that I talked about first. Is this open source and maintainable? Do they have a clear governance model? Are they built for non-running in just your hyperscale data center solution? Are they built for multi-cloud? And then inside that, you will pick things along these privacy, verifiability, and performance access. We have a compute over data working group that is growing very quickly, and you can see the teams and folks who have built into the open source platform here. The QR code in the lower right will take you to our homepage. We have bi-weekly meetups and so on. And again, you see here just a ton of people. We just started this in the middle of last year who have already signed up and are participating in it. And one thing I want to do right now is talk about some of the advancements that these teams have done over the past year. And again, this is all them, working on inside of Juan's triangle, like figuring out exactly what their particular needs are and pursuing it. We start with Spice AI, who's released a brand new platform for processing data and things like that using Web3 and other next-gen data sets. Polybase just launched. They are in testnet right now with validators and did their fundraise. They understand natively tokens, ZK proofs, and wallets. You have Ceramic, which just launched ComposeDB, which allows you to do compute over data, but in this case, using a graph database. And again, they've announced partnerships as well. The Koi network is launching with both a desktop node and servers. And you can see a number of their different scenarios, particularly for those widely distributed compute networks. Gridcoin just launched folding at home integration, and you can see a number. They've already been in market, and people have been using them for quite some time with the amount of coin they've already paid out. You have Fat Contract, which is really focused on the programming models, but they have a number of features that you would expect from like any compute over data network, internet connectivity and templates and so on and so forth, really focusing on making developers much more productive. And NewNet, one of the sponsors here today, who is currently working on the global display of decentralized compute, especially in a peer-to-peer type scenario. They are currently in public testing. Oh, and finally, sorry, this is the example that I referenced earlier, Blocks.io. They are in market right now in proof of concept with the city of Las Vegas around that very scenario that I was talking about earlier, around using cameras and so on and so forth. So, like I said, this is our 2-day Compute Over Data Summit. The talks and things are all up on our schedule. You can also always go to codsummit.io, where our schedule is front and center. And we have just an absolute ton of talks and demos and things over the next 2 days. And again, our key goal here is to have all of you work together. It shouldn't be listening to the folks that are here on stage. It should be working together to help identify scenarios, interfaces, common ways for us to interact back and forth in order for us to work on, here are the commodity elements, and here are the places that we're going to take advantage of in order to go and build what's next. And with that, I am done. I have just a minute for questions if anyone has any. Other than that, we'll invite up our next speaker. Any questions before I get going? Okay. All right. Thank you so much.